Okay, here we go. I'm curious to see what you have written down. So, we're talking about theoretical probability. It's all about chances, all about games. So the rules that I gave you were, you had to use that spinner. Now it's a spinner, so you just flick it. Totally random, right? There's only 2 players. You have to decide what are the rules of your game. Does somebody mind sharing? All right, Nicole, tell us what you put for your rules for the game.
Okay, so first, whoever spins the highest number goes first.
Hold on, I'm going to repeat after everyone. Are you okay with that? So you said whoever spins the highest number is who goes first. That's a fair rule. Okay, keep going.
And then you stop after you spin the same number 3 times in a row.
Ooh, you stop after you spin the same number 3 times in a row. And then it's the next person's turn.
No, you go, so like you go back and forth with the spin,
Uh-huh.
and you have to, not each person spin 3 times in a row.
Oh. So like I would spin, I'd get a 3, and then hopefully you would spin and get a 3, and then hopefully I'd spin again and get a 3. Whoa, it's a fantastic game. All right, anybody else? These are the rules for my game, 2-person game. Gloria, what'd you put?
Same as whoever spins the highest number gets it.
Okay.
Whoever gets to 21 first, like you have to keep track of the numbers,
Oh.
wins. But the black ones take away from your score, like you minus however many numbers there are, and the white ones add to your score.
Wow. Okay. Let me unplug this real quick. All right, so Gloria said, same thing as Nicole. The first person, well, when you decide who goes first, whoever rolls the highest, spins the highest, goes first. And then she said you're going to 21, right? So whoever gets to 21 wins. However, you said if you land on one of these black slices, it takes away from it.
However, that one black
Wow.
has 6, take 6 away.
Perfect, I like that. So you added negatives into your game. That's fantastic. All right, let's get one more person. One more person mind telling us what were your game rules. Carrie, go ahead.
The youngest goes first.
Youngest goes first. Keep going.
If you land on the skunk, you miss the turn.
Ah, if you land on the skunk, you miss your turn. Keep going.
You stop when someone hits orca 3 times in a row.
You stop when what?
Someone hits orca 3 times in a row.
Oh, you stop when someone gets the orca 3 times in a row. I like they said orca.
Highest score.
And then the highest score. Yeah. Okay. Nicely done. How many of you? I like my game. You like the rules you came up with? Okay, I have a question for you then. We're talking about theoretical probability, all about games, all about what should happen. Looking at this spinner, do you think it's a fair spinner? Do you think it's equally likely to land on the cow as the penguin as the zebra?
Yeah.
Right, we're just flicking it, right? Now, could you have tweaked your rules and made it not fair? Yeah, totally, right? So it depends on, spinner depends on the rules, whether a game is fair or not. So look at these next spinners. This spinner, what do you think about this? Is this fair? No. Hand in the air. Tell me why letter A spinner. That was not a fair game. If you're just flicking it and spinning it without knowing any other rules, how come this one is not fair? Thomas, what do you think? Perfect. All right, so you said the orca has the biggest degree. It has the biggest space. So is it more likely to land on the orca or the penguin? Orca, right? That is not fair. All right, could we tweak the rules and maybe kind of make it fair? Maybe. It would be a little bit rough, right? Because it's totally random. All right, what about letter B? Do you think that spinner is fair or not fair? Which one are you going to probably land on the most? The dog, he is equally more likely, right? His probability is higher. Which one is the least likely? Oh, cow, skinny cow, 15 degrees. Okay, so you've got that. Okay, right up here, will you go to page 213 in your workbook? Make sure this is working out. Okay, good. Page 213, it's like middle of the page, right, where it says what's your answer. First thing I want to go over is how can you find a theoretical probability. Okay, theoretical probability is what should happen. Keyword should. I'm going to underline that keyword. What should happen. Okay, probability, all about games, all about chances. Oh, I've got one. I can think of an example for you. Let me change this. So, example, what if we are just flipping a coin? If we're flipping a coin, what could we flip? A what or a what? wait, heads or tails? That makes sense, right? One side is heads, one side is tails. All right, what if I said flick your coin 10 times and then write down what you get every time? So pretend flick it, lands, and then you look at it, look at your pretend coin, and they're like, oh, cool, heads, and you would just write it down. Or, yeah, tails, and you would write it down. So if you flick it 10 times, you flip that coin 10 times, how many times should you get tails? You should get tails 5 times, right? So that's theoretical probability, 5 tails. How many times should you get heads? All right, that is theoretical probability. In theory, what should happen? All right, if we're flipping a coin 10 times, are we always going to get 5 heads and 5 tails? No, wait, because it's totally an experiment. It's totally random. Does that make sense, the difference? Theoretical probability, what should happen, and then experimental probability is what actually happens when you flip it and record it. Oh, wait, number 5, kind of take some thinking. Number 5, find and describe a career in which probability is used. Career, what's another word for career? All right, so a job that uses probability. So where they have to decide, all right, this should happen, but this is what actually happens. I'm just going to watch the clock and give you a little bit of thinking time. Write down any job that you can think of, but here's the other kicker. You've got to tell me why probability is used in that career. So write down the job if you can think of one, and then say how they use it. Definitely. So Gloria said casinos. Casinos use this with the workers. You know, they're playing against you. Casinos are all about probability. With casinos, guys, do casinos make a lot of money? Yes, they make a ton of money. Why? Because people go to casinos thinking of theoretical probability. This should happen. But does it happen? Rarely. So casinos make big bucks off of that money, off of that idea. Go ahead, Xander, what else do you think?
I did a baker.
A baker. Tell me why a baker uses probability.
Like when they put a bread in the oven, it should like puff up and turn into a yummy bread. Sometimes it like collapses.
Wow, good work, good work. Okay, this next one is tricky, but all right, number 5, 2 people are playing. Each player. All right, so first let's just draw our 6 cards. 1, 2, 3, 4, 5, 6. Okay, so we each have 6 cards. And what you do, since we can't hold up our cards, we're just going to put our finger on it. So everybody choose a card, put your finger on it. Okay, I'm going to put my finger on this one. All right, this is a game of 2 people. So, Jose, what number did you choose? 3. I chose 2. So here's what, oh, we have to decide who's player 1 and player 2. We'll come back to it. All right, I chose 3, he chose 2. We multiply them. So what's 3 times 2? Is that an odd number or an even number? Even number. Okay, Jose, let's say you are player 1, and I'll be player 2. Okay, here's where I have to write it down because I get confused. Up in the directions it says if the product is even, player 2 wins. Oh, that was totally random. I didn't mean to make myself win on the first one. I'll be evens, Jose, you be odds. Done right? Okay. Next one. Same thing, Jose. You guys can play along with this. Start over. Fingers up. Look at your cards. Put your finger on one of the cards. All right, Jose, which one did you do? 4? We both did 4. All right. So 4. So what Jose and I do is we do 4 times 4. What is it, guys? Dangerous. 16. Is that even or odd? Uh-oh. Who won again? Okay. Jose, let's play one more time. Are you ready? Okay. Put your finger on one of the cards. Okay, what'd you choose, Jose? All right, I chose 1. So we've got 1 times 3. Even or odd, guys? Odd. So who wins? Guess what? Do you think this game is fair or not fair?
Not fair.
Okay, are you saying not fair because I've won twice already? Are you saying not fair because you've already figured it out? Because guess what? It is not fair, but you've got to figure out why. Let me highlight this. Right here it says which player is more likely to win. One of us has the advantage. Either Jose or I. I've only played 3 times. You want to play lots to figure out, but one of us is going to win majority of the time. So think about it. If I'm evens after we multiply, and Jose's odds, one of us has the advantage. Nicole, you figured it out? Who has the advantage?
All of the methods are hard, no matter, except for like the 1 and 3, 1 and 5. All of them hold equal.
Right here. Oh, I thought I left highlighter. Let me go back. Here, what Nicole just said is that the even person has the advantage. Think about this. If someone ever chooses a 2, what happens with your product? Is it even or odd? Even. What happens if someone always chooses a 4? Is that going to be odd or even every time? Are you sure? Because what's 4 times 1? 4 times 2? 4 times 3? 4 times 4? 4 times 5? 4 times 6? Those were all what kind of numbers? They were all even numbers. And then check out this one. What about 6s? What happens when you multiply anything by 6? Does it come out odd or even? Even. That is a ton of evens. So evens has the advantage. How many of you? I get that now. Now we've told you. Does that make sense? That was not a fair game. Okay, this one's what we already talked about. Guess what? You've been doing theoretical probability this whole time. It's what should happen over how many. So keyword, what's the keyword for theoretical probability? Should. Just remember, should happen. Okay, right here. Just find space on your book, maybe by those spin wheels, the unfair spin wheels. It says, we randomly choose one of the letters shown, these letters right here. What is the theoretical probability of choosing a vowel? What should happen? So how many vowels are in here? How many total block letters? All right, so, yeah, I agree. So our theoretical probability, what should happen is we should pull 3 vowels out of 7 total. So that's saying, if we experimented and we took out 7 letters, I marked them down, we should have 3 vowels. Now, do you think that's really going to happen? Probably not, because it's totally random. But that's theoretical probability. Grab your calculators. Change this to a decimal. Grab a 0 point something. 4-3?
Yeah.
All right, what percentage is it? 43%. Guys, you rock that. Good work. Okay, let's look at this one. Oh, this is a fantastic one. What are we pulling out of the bag? Marbles. It already gives us the probability. The probability is what? 3/8. So the probability of choosing a green marble is 3/8. Well, how many marbles are in that bag? Guys, you can do this with a proportion. Are you guys good at proportions? You're like the best at proportions. You just gotta think, where does the 40 go? You all said bottom. How do you know it's in the bottom? You did that so fast. Kylie, how come? Why do you think it goes right here?
It's the biggest number and it's the whole bag, and the 8 is the whole bag.
Perfect. It's the whole bag. So grab your calculator. Cross multiply this bad boy.
It's 15.
15 what? Oh, I like that you said green. So there are 15 green marbles in the bag. So the probability is 3 out of 8. That's a simplified probability. Okay. This part, just look at it. Is this spinner fair?
Yes.
Is this spinner fair?
No.
Okay, last class said yes on that one. Maybe it's a trick of the eye. Which one is most likely to be spun on this? 1 has the advantage, right? Okay, this spinner, is this spinner fair?
Yes.
What's the probability of spinning a green?
2 out of 6.
Okay, simplify it.
1/3.
Grab your calculator. Change that to a decimal. That's a good one to memorize. What percentage is that?
3%.
Guys, you rock this. Okay. I'm going to say start your assignment. Open up to page 214, problems 1 through 7. Let's make sure you understand the directions though. Okay, are you all there? 214. Okay, remember how we laughed at this? Number cube, what are they talking about? A dice. How many numbers are on that?
6.
Okay, right here, rolling a 2. How many 2s are on there?
1.
Out of how many numbers?
6.
So first, put your fraction. What's the theoretical probability of it? Some people were putting 2 out of 6. Why do you think they're putting 2 out of 6? It says 2, but it's saying rolling a 2. There's only 1 2 on there. Okay, don't forget to do your decimal. You've done this before. Do you have it memorized yet? Do you know what decimal that is? Round it. Be very careful because it's 0.1666666. Round it to that. So percentage is? Okay, go for it. Don't forget to do fraction, decimal, percent. Pay attention to your directions.